In this video, you're going to learn everything you need to get up and running with the Riskfolio library here in Python. It's a really great tool that allows you to apply a lot of mathematical finance concepts for maximizing your return or minimizing risk and have those all at your fingertips without having to pore through loads of academic papers and implement the models yourself. I've done videos before on portfolio optimization, and I can definitely say this is the easiest library that I've used to calculate things like the efficient frontier. And it also has a really cool system for adding constraints on your portfolio. Like you can specify that you want at least 5% of the portfolio to be, say, Bitcoin, or that you want to have at least twice as much fixed income assets as you have in equities. Super easy to apply rules like that using what is essentially a Microsoft Excel interface. And by the end of this video, you'll be more than ready to explore the other functions in this library for yourself. So let's get strapped in and boot up a Jupyter notebook here. So for once, I'm not using Vim, and that is because this library has some really great visualizations that they don't come across very well in Vim, obviously. And the default matplotlib display doesn't quite do things justice, so I'm going to run this code in a notebook. Now you'll want to install Riskfolio. The instructions are here on the documentation. For me, all I had to do was pip install and everything worked great. They do recommend using Anaconda if you're on Windows, which is probably a good idea to install all your dependencies. That's going to look completely different for each operating system, so I'm not going to spend too much time on that right now. So the first thing we need to do here, obviously, is we need to start importing some functions, and we also need to get our data. So let's import yfinance. That's the model that I'm going to be using here to get our data. Now, yfinance is pretty good for daily data overall. That's why I'm using them here. If you need some smaller time frames, then I'd really recommend, either directly scraping the data from an exchange or using Polygon or something like that. .pyplot as PLT. We'll need that to make sure everything shows up. I'd also really recommend importing warnings here. And then doing warnings.filter warnings ignore. Now, what this is going to do is basically all of the normal warnings that pop up, they won't pop up. For some reason, this library has loads of them, and so just ignore them, basically. So, okay, let's get some data here, and I'm going to do that by just specifying a start and end date. So let's say 2019-01-01, so the 1st of January 2019, and then let's have an end date here of 2022-01-01. So that's going to be the range for our data. We now need to select our universe of assets. So I'm just going to have a few here for now. We can always expand this later on. So we'll start with Bitcoin and ETH USD. Maybe we'll add in something a little bit rogue like Litecoin, for example. And we'll see how that affects things. Once we've got that, pretty easy. All we need to do is do data is equal to yf.download assets. Start is equal to start and end is equal to end. If we run this block here, that should print everything out if I do data here. There we go. You can see we've got all this stuff. We want the adjusted closing price. Let's run this cell again. And what we actually need here is we need the percentage change. So I'm going to have returns is equal to data, adjusted close, dot percent change, just a regular pandas function here, dot drop NA. And obviously there's no day change from before this one, so this is going to be a NA value. You want to remove that in your data set. The return is going to be consumed by the optimizer Obviously, it needs to know how it's performing day on day in order to figure out what the best portfolio is. So now we need to do some setting of things. I'll try and give brief explanations of what's happening as we go on. So method mu here, I'm just copying these from an example I found in the documentation. We're going to set to hist. So hist is historical, and mu here is mean. So a lot of these financial models require that you give them values for the mean and the covariance. And hist is short for historical. And basically that means we're going to use the data that we have so far, calculate our metric on that data, and assume that's going to carry forward into the future. That's what historical does here. There are a few other models built in, which we might look at later, but all you'd have to do is just change the value of this variable, essentially, and everything else will be the same. So, similar sort of deal for calculating the covariance here. I'm just going to use the historical method, keep things nice and simple. There's also a model here, parameter, and I'm going to call it classic. There are also options for the black litterman or the factor model for all you nerds out there. Next, we need to provide a risk model. So MV is just going to be the standard deviation, or just the variance. So in this case, our optimizer is going to assume that the variance and the risk are the same thing. There are lots of other risk models in here, and I will cover those in a minute. But for now, we're just going to use this as a proxy for risk. We then need an objective function. So you have a few options here. You have minimum risk, maximum return, utility, or sharpe. I'm going to leave mine as sharpe for now. So we're going to try and maximize the sharpe ratio of this portfolio, and our risk measure is going to be the standard deviation. We also need to provide a few other things in here. So we need to provide the risk-free rate. I'm going to set that to 0. And then apparently we also need this risk aversion factor. This is only used if you're using the utility objective function, which we aren't, but I'll provide it anyway. So this is basically setting all of our variables that go into the calculation. So maybe I'll add a little cell here for variables. And then in the next cell down, we'll actually do our optimization. Here, I'll create another heading, and we'll have maybe optimize. And then we'll create a portfolio object here. So we'll do port is equal to RP. I believe we imported Riskfolio as RP up here. RP dot portfolio. And then we need to provide the returns here. So returns is equal to returns. I believe that's what we called our returns data frame up here. So that's going to initialize the portfolio object. We then need to let it calculate some statistics about the portfolio. So to do that, you do port.asset_stats. You only use this for the classical one. There's a different method for the black litterman and the factor model if you wanted to use those instead of this classic model here. But for the classic model, you just need asset stats here. And then we basically just pass in the methods that we're using to calculate the expected return and the covariance. So method mu is equal to method mu, and method covariance is equal to method covariance. So that'll calculate some stuff that our optimizer is going to consume here. And finally, we're ready to grab the weights of our optimum portfolio. So we've done our configuration, and all you have to do here is port.optimization. Model is equal to model. Risk measure is equal to risk measure. The objective function is equal to our objective function, which we set. The risk-free rate, the risk aversion factor, which we don't really need, and we set hist is equal to hist. Again, we're using the historical method to estimate these parameters. So let's run this. Should only take a second or two. Apparently returns isn't defined because I spelt it wrong. I'm having a really bad day with spelling. It's assets stats, not asset stats. And I believe we also need to run this here before we can do that. We also need to define the hist here. So hist is equal to true. Okay, that should be the last of our errors here. That's come through. So let's print out W and see what that looks like. So basically, it's completely disregarded Litecoin here. You can see, well, it's maybe a bit difficult to read in this format, but you've got 1.842 e to the minus 9, so basically a very small number. And then it looks like we've got 63% ETH and 36% Bitcoin, basically. Now, obviously, this is, well, it's useful, but it's a little bit difficult to read. We might want to use some of those nice plotting functions that I alluded to earlier. So let's try that here. I'll add a little markdown thing here, and we'll do plotting. Okay. So the simplest kind of plot that comes with Riskfolio here is the pie plot, and that'll just plot out a nice pie chart showing us exactly the ratios of different assets that we're buying here. Ax is equal to rp.plot_pie. I believe this library uses matplotlib as the underlying plotting library, so some of the syntax might be a little bit familiar to you. We can set a title here. I'll set mine to optimum portfolio. You can set the others parameter. So basically, how small does a slice of the pie have to be before it gets lumped into others? So I believe this will mean it'll group the bottom 5% into an others pie. You'll see that in a second when I show you the graph. We can select the color mapping. The one that's in the documentation is tab 20, but feel free to mess around with this. And I think that should be good if we do a plt.show here. And we'll try and run this. There we go. So we've got a nice graph. I'll zoom out a little bit. And basically, like I said before, 36% Bitcoin, 63% Ethereum. Now, again, like I mentioned, this is going to be very dependent on a few different things. So you can change the objective function here, for example. So this is trying to optimize sharpe ratio. But what about if instead of that, we wanted to minimize our risk, so min risk. And if I run this, run our optimizer again, and run our plotting, looks like it got a 0 division error, but it still showed everything here. I have noticed that actually with this library, if you get a 0, it doesn't like it, but we can print out the weights here. And you can see that it's basically 100%, well, it is 100% Bitcoin, and that's why it's getting these 0 divide errors. If we were to try something like max return, let's see what that looks like. So now you can see it's basically 100% ETH. I think it's going to have the same problem plotting. Obviously, this is just due to the particular features of these currencies at the times in which we're looking at the data here. If you were to look over a variety of different time periods, this data would look very different. It's essentially just telling you to go all in with a particular asset. Later on in the video, I'll show you how to apply constraints to this so that we could say you've got to have at least 5% of all of the assets, but beyond that, the optimizer can decide. A bit more of an intelligent way of doing things rather than just naively optimizing like this. So okay, I'll change this back to sharpe for now, just so that we get a portfolio that's a little bit more sensible and that will actually display here. So there we go, we've got our 63.4% ETH and our 36.6% Bitcoin portfolio. Now for my next trick here, I'm going to plot the efficient frontier. If you don't know what that is, you'll see it in a second. So we'll say frontier, well, that's equal to port, so our same portfolio object, dot efficient underscore frontier model is equal to model, so classic. Our risk measure is the same as before. We're going to have 50 points on this efficient frontier computed. Risk-free rate remains the same, and hist is equal to hist. So that'll go ahead and calculate that, and then we need to actually plot it out. So it's a similar sort of deal. We have to deal with defining a new axis here. So it's going to be rp.plot frontier. I'll give this a little bit more space here so it's easier to read. Provide that frontier object that we just created there. So W frontier is equal to frontier. We need to provide the expected returns and the covariance matrix again. So mu is equal to our portfolio.mu. So we can just grab those statistics straight from the portfolio. Covariance is equal to portfolio.covariance. Returns is equal to returns. There are quite a few different inputs on this, so bear with me. Our risk measure, again, is the same as before. The risk-free rate is the same as before. And then we'll provide a color map as usual. So again, pick your favorite color scheme here. I'm going to use Viridis. Always a nice one. And then finally provide the weights here, and that should do it. So do plt.show. If I run that, points isn't defined because it needs to be set to something. So I'll set that to 50. And there we go. So what we have here is the efficient frontier, which, if you've never seen it before, basically shows the expected risk against the expected return. Now, with this model, pretty much all the time, in order to get a better return, you have to take on more risk. That's assumed to be just how the model works. And so our risk metric that we used before was the standard deviation. That's the one that we set earlier in our parameters. And each of these dots is going to represent a different portfolio with different ratios of the 3 different assets that we've specified. As you go further along to this side, you have lesser variance, so basically lower drawdowns, less highs and lows in price, but your expected return here is also significantly less than what you're getting up here. I'll show you how to look at what these dots represent in a second, but usually at the extremes here, you'll normally have 100% of one particular asset, at least when you've got a small universe of assets like the one we have here. This red marker here is our optimal point, which we calculated. Again, when we set up our variables at the beginning, we told it to calculate the point with the best sharpe ratio, which is basically the returns divided by the variance. And so it's this portfolio that we plotted out earlier. But there's a whole world of other different portfolios here that you could potentially choose from. Some that would give you higher returns, but also significantly higher risk, according to this metric at least. If you want to look at what these individual portfolios here look like, you can just print out the value of the frontier here. So if you print that out, you'll just get a regular data frame, and each number here represents a dot on this curve. So 0 is going to be the one to the most left point. And you can confirm that and just do a quick sanity check here. And of these 3 assets, Bitcoin is going to have the lowest variance of the 3, but also the lowest returns over this time period. We can see that Litecoin never gets included in the portfolio. So at least in theory, if your universe consisted of these 3 assets, you should never really be picking Litecoin in your portfolio, at least on the time frame that we've looked at. This can be a little bit difficult to read. It's not the clearest thing in the world. So if you want to plot these data points on a graph, there's a nice inbuilt visualization that comes with the library. Similar sort of thing. You ax is equal to rp.plot_frontier_area. Again, we provide that frontier object again. So w frontier is equal to frontier. Provide a color map. I'm going to use our trusty tab 20 here. And I think that should be good if we do a plt.show here. So I'll zoom out a little bit so we can see it. Basically, the x-axis here is the number of the dot. So this is the first dot, so on and so forth, till we get to the 50th dot. And basically what you see is that we never have a sizable chunk of Litecoin, and that the further you go out on the risk curve, essentially the more Ethereum that you take, given this setup and universe of assets. It can be quite cool to look at these 2 charts simultaneously, especially if you've got quite a few different assets. You can see how the portfolio composition changes as we add more and more risk into the mix. I'll go through that in a second, and we'll add a few more assets in there and tweak some of the different parameters to get something a little bit more interesting. If you wanted to plot out any of these individual data points in a pie format, rather than having them like this, which, it can be a little bit hard to read if you want a specific portfolio, you can always go and grab your trusty pie chart graphing over here, pull that down here, and we can just grab the frontier and just pick the index that you want. So let's say I want the 23rd object. I'll go grab that. It'll probably complain and say it must be a data frame. So let's just import pandas here as PD, and then we can convert this thing to a data frame. And there you go. So you can change this to 20, or maybe 14. And that's going to plot out all the different portfolios. You could do as many as you want here. You could even run a for loop and plot them all out if you really want. Just thought I'd show you that. It's a cool way to extract the weights from this frontier object, so to make things a little bit more readable. So the final sort of plotting / reporting feature I'm going to be showing here is a Jupyter report, at least that's what it's called. So similar sort of thing, we define a new axis here, and we'll set that equal to rp.Jupyter report, and we'll provide the returns, the weights in our portfolio, the risk measure that we used. So I think we can just set that equal to RM is equal to RM. Everything else, I think we can largely leave as default. So let's do a plt.show here. So what this will do is it'll give us a nice printout here. So you can see things like the mean return, standard deviation, all this nerd stuff. You can see the historical returns here over time, the composition, a nice pie chart, how much each asset contributes to the standard deviation. You can see potential sort of drawdowns and the different probabilities of those drawdowns occurring, given different models here. You can also see the drawdowns that actually occurred, how bad they were, and you can do that for every single portfolio here. So like we did before, you could easily grab this with pandas from the frontier here. So you can do frontier, say number 34, grab that one, wrap it up in a pandas data frame, and you're good to go. And you can run a new Riskfolio report here. And so you can look at these different reports for each individual portfolio on your efficient frontier here. One thing that I've just noticed here looking at this is using 252 as the multiplication factor for annualizing this data. We're using crypto data here, so realistically that trades 365 days a year. And so for that, you're going to want to add a T factor in here. So T factor, and you're going to set that to the number of days that gets traded. So in our case, it's going to be 365. Crypto trades every day. And then our stats will look a little bit more realistic here. You may want to stick that in a few other places that I've forgotten about, but it just makes sure that the values here are properly compounded, accounting for every single trading day. There's also a days per year option, apparently, that we need to change. So days per year is equal to 365. And that'll change the compound annual growth figure that we saw earlier. This one. Make it a little bit more what we're after. So let's have a little bit of fun with this model, change some of the things, and see how that affects what's going on. So the first thing I'm going to do up here is I'm just going to add some more assets into the mix. So we'll add more crypto. So we'll say Monero, let's say. We'll add some Link. We'll add some other random coins. We'll add Doge in here. Let's see what the optimizer comes up with. So we'll download all of that, calculate our returns. We'll use the same variables here for now. I'll show you how to change that in a second. We'll run our optimizer, lightning quick. So what's it coming out with for the weights here? So basically, we're making use of all of the assets except for Litecoin and Monero. Let's plot that out as a pie. So this is maximizing Sharpe ratio, remember? So this is maximizing our returns when divided by the amount of risk. So obviously giving a massive weighting to Link here. I'd suggest that's largely because of the time frame that we chose. Maybe if we chose a different time frame, this would look different. Again, something you're going to have to be very, very careful about when testing your own portfolio. Probably want to run this across lots and lots of different time frames. Come back down here, recalculate the efficient frontier. Now looks a little bit funky because we've added more assets into the mix. But I think, at least according to the model here, we seem to have increased our expected returns while keeping our expected risk roughly the same, which is quite cool. That's because we have more assets, and in theory, they're not perfectly correlated to each other, so we'd expect to see some differences. This plot should look a little bit funkier now as well. So you can see, as you go from lowest risk to highest risk, the percentage of Doge that you add to your portfolio increases apparently, and so does the amount of Link. ETH finds its ecological niche in here, and you basically stop using Bitcoin after you get to the 10th point. Again, we can run a nice report here, so let's run that on our actual best portfolio. So we'll do that on weights here. Going to give us a bunch of information, what the compounded returns look like. This is crypto, so obviously it looks insane. Interestingly, drawdown isn't that big from the peak. And then, yeah, our usual different stats here. So let's have a little look at a couple of these values and just to show what they do. So as I said before, we've got min risk, and that's going to pick the minimum risk portfolio. So I'll run through this very quickly here. And if I come down to our efficient frontier, you'll see that it basically just picks this portfolio. So the portfolio furthest to the left, or the one with the minimum expected risk. The efficient frontier can look very different depending on the methodology used. It doesn't always look like a perfect curve like this. So if I plot this portfolio out, it's probably just going to be 100% Bitcoin, nearly 100% Bitcoin, 6% Monero. You can do the exact same thing in the other direction. We can say we want the maximum return, which according to our model is going to give us more risk. And so if we plot that one out, it's probably just going to be like 100% Doge or something. It won't show because of that division error, but we can compute it on the efficient frontier here. And we can see from our graph that it would be 100% Doge. We can also mess around with our risk metric. So right now we're just using the variance, which many people would argue isn't a particularly good method of looking at risk. So let's put this back to Sharpe here. I'll just copy and paste a big list of these different methodologies that I found here. So I'll go over here and we'll paste them out. So as you can see, there's quite a few. Let's play around with a few and see what happens. So maximum drawdown, so our risk is going to be proxied by the max drawdowns, or the Kalmar ratio. So let's try that MDD in here. Super quick again to run this. Let's see what it comes up with at that pie. Interestingly, a Doge ETH portfolio minimizes drawdowns. Who would have thunk it? Again, very important to run this over multiple different time frames. I'll do that here just to show how things will change. I imagine they'll change quite drastically. If I set this to, let's say, 2021 and rerun all this stuff, yeah, suddenly we've got 100% portfolio of something. Who knows what it's going to be? Let's have a look. It's still recommending 100% Doge. That's pretty funny. But yeah, as you can see, the values it spits out here for the portfolios depends quite a lot on your range here. So I think it's useful at this point to start adding some constraints to the optimizer. And that way you can force some sanity on the optimizer. And it won't do stupid things like blindly tell you to put 100% of your portfolio into Doge. You can add some constraints to construct a portfolio that you can actually live with and just tweak it a little bit by using an optimizer. Obviously, there are more options than I could ever hope to cover in one video as far as all of these different methodologies go for calculating your expected returns, your covariance, the different models, the risk metrics, so on and so forth. So let's move on to thinking about constraints and how we can add those to this portfolio. Now, there's a super simple method of adding some constraints. So I'll make the data go back to 2019 here, so it's a little bit more sane. And the simple way of adding constraints to this is we can add a constraint on something like the maximum drawdown that we experience. So we can say, okay, optimize a portfolio for us, but make sure that we never have more than a 40% drawdown, and then optimize for whatever we've told you to optimize for. So basically, you can do that by accessing this port object here. So if you port dot upper MDD, so maximum drawdown, and you're going to set some value here. So I'm going to say equal to 0.4, so a 40% drawdown. And let's see what it comes up with now as the best option. So you can see it doesn't actually have a solution. If it uses the universe of assets that we've given it, it can't come up with a portfolio that has less than a 40% maximum drawdown. So if we change that to 60%, again, apparently it can't come up with anything. So let's try 90%. It should be able to come up with something. We'll reduce this until it starts speaking some truth to us. Okay, so the weights here, looking slightly more reasonable, not going 100% Doge this time. You can also impose things like a minimum return. So you can do port dot lower return is equal to, I'll just set it to 0.2. So we expect at least a 20% compounded annual growth. And again, it is possible to add constraints that don't actually give you a solution. So apparently there's no solution here. I believe this is complaining here because this is the daily returns, not the yearly returns. So you just do whatever you want your returns to be. Let's say 20% divided by the number of trading days. In this case, it's going to be 365 because we're trading every day of the year. Okay, so we've managed to find that portfolio. It's probably going to be the same one as this one. Yep. Let's crank this up. We want 90% annual returns. Let's see if it comes up with something. Still the same portfolio. Let's try and reduce the maximum drawdown and see if it can come up with something better. As you can see, the amount of Bitcoin in the portfolio has increased pretty dramatically. So you can have a real large amount of fun setting all of these different constraints for your optimum portfolio, running that over different time periods, and making sure that the strategy is sound. Theoretically, the more data you have, the more accurate this should be, unless there's been some big regime change in the market. There are lots of other functions here that you can use to apply constraints. Basically, you can find them all at this link here. So I'll add this in as a comment. I'll also visit it here just so I can show you. So if we go over here, basically there's a big list of them down here. So lower return, upper standard deviation, so some max limit on the volatility, some max level of GMD, whatever the GMD is. Yeah, you can really go to town with this and pick your favorite metric and try and constrain it such that you don't get really stupid portfolios like 100% Dogecoin. So that's well and all, but that's kind of limited in how we can specify things. We might want to say something like, we have a portfolio of different stocks, for example, or we might just be a regular index fund investor. But yet we want to add some crypto into our portfolio to juice the returns, but we want to make sure that we never go over 10% crypto. How could we give the optimizer restraint like that? The way that you do this is by creating a number of CSV files and then importing them to Pandas as a data frame. You can also use them as raw Excel files, and Pandas can read those in just fine as well. So that gives it kind of a nice UI to add these constraints. I've got a couple of examples here that I whipped up earlier, and I'll show you what they look like and how they work. So we've got two CSVs. One is called constraints.csv, and one is called assets.csv, or asset classes.csv. So one of these is for labeling our different assets. So we've got our assets here. We've got Bitcoin, Ethereum, Monero, we believe we've got Link, we've got Litecoin, we've got Doge. I also added a few equities in here. So let's add VOO. I'll get rid of this one for now. We don't really need it. This is a treasury fund if you're interested. So VOO is the Vanguard S&P 500 fund. So let's add that in here. So VOO. So we've got this CSV, and we can add different labels to each of the assets. So this is a label that I've added here, and this label is called class 1. We could also add another label called class 2, and maybe I could label them, let's say, safe and unsafe. So safe, safe, unsafe, 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 safe. These labels are completely arbitrary. You choose whatever you want and however many of them you like. It's just a way for you to label the different assets and the different asset classes. You could also have something like industry that might be a bit more useful. So industry. If you've got different stocks, you want to label your raw material producers, your energy companies, financial companies, etc., etc. And that way you could add a constraint on, let's say, no more than 10% of your portfolio should be in financial stocks or mining stocks or something like that. Now I'm not going to do this. I'm going to make things very, very simple here. All I'm going to have is a class telling us whether they're equities or crypto. That's all I want. And this is going to let me put a cap on the amount of crypto in my portfolio. So that's the first CSV file here. Let's incorporate that into our notebook here. So what I'll do is I'll probably get rid of this, and I'll do pd.read. So let's say assets classes is equal to pd.read.csv. Provide the name of this file in my folder here. It's called assetclasses.csv. So assetclasses.csv. And then from here, assets, well, assets are just going to be a list of asset classes, assets. That way, just everything's in tune with what we've got here, and we don't get misaligned where we have more data or something. One thing that's super, super important here, and I learned this the hard way, is that you definitely want to sort this by the asset name. So you want them in alphabetical order. So you sort underscore values, and then by is equal to assets. And that'll give us all of our assets that we need. And I'll also load in this constraints file here. So constraints, well, that's just going to be equal to pd.read_csv, constraints.csv, and that should be good. I'll print it out just for good measure. Constraints. So you can see it's taken this CSV file that I've found here, which is quite intuitive to use. So this is the example that I played about with earlier. So you can see, well, disabled false, that makes sense. This rule is in action. Type is classes. So the options are classes and asset. So you could have a rule for a particular asset, or you could have a rule for a class of assets. Now, in my case, I've let this rule be over the classes. Which class do I want it to affect? I want it to affect class 1, which is the only class I have set up. I want it to affect our crypto position, and I want to make sure there's at least 10% crypto in the portfolio here. If I flip this sign, I now want less than 10% crypto in the portfolio. Super, super simple here, and the nice Excel interface makes it a really pleasurable experience when you're trying to optimize portfolios. You can have this on one screen, you can have your notebook on the other, and you can flip back and forth super easily. This one here is a little bit more advanced. So what this is doing is it's comparing two classes. So it's saying the class of equities, well, I want that to be more than or equal to the fixed income class times 0.5. So basically, I want to have at least double the amount of equity that I have fixed income. That's what this rule says here. Again, a couple examples in the documentation that can get you going, but these are the ones that I'm going to be using. I'm going to get rid of that one because we don't really use fixed income, at least not in this example. But it was just to show you what these other columns do here so that you could use them for yourself. So I'm going to say I want less than 10% crypto, and we now need to apply that constraint into our optimizer. If we run the optimizer now, it won't understand the constraints that we put on it. It'll just optimize things as normal. I mean, we can see what would happen if we do that. It might be interesting. But I don't think, yeah. Basically, it advocates for S&P 500 and Doge. Again, an interesting choice of portfolio. In order to let our optimizer take in this information, we basically have to run it through a function which is going to return two matrices. I wouldn't worry too much about the contents of these matrices. You can look into it if you want. But basically, there's a function called assets constraints. You apply the constraints to the assets classes, and that'll give you two different matrices called A and B, which provide the rules which we can give to our portfolio object here. So it's A inequality is equal to A, and B inequality is equal to B. It's called A and B inequality because these matrices are such that they satisfy certain inequalities concerning the weights, which actually enforces our rules. But basically, add these two lines in, and then whenever you change these rules, they'll be updated. So we'll go through a live example here. So hopefully, if I click run here, we should have a very, very small amount of crypto. So if I run this now, you can see it's basically advocating for a 90-10 Dogecoin S&P 500 split. Now, it's been a persistent theme through this video that this Dogecoin has been a thorn in my side. And perhaps we do want some Dogecoin exposure, but we don't want it to take all of our crypto exposure. We want some other assets in there as well. So let's add another constraint here just for fun. So we'll do false. Well, let's make sure this is a string, actually, because otherwise it might complain at us. Make sure this is formatted properly. False. What type is it going to be? It's going to be assets. You don't need a set because this is an asset. It's going to apply to Doge USD. I think that's the format that we used here. Yep, Doge USD. The sign, well, it's going to be less than or equal to. And then let's set a weight of 0.02. So you can't have more than 2% Dogecoin, which I think is fair. Go back to our notebook here. Reload our constraints. Rerun our optimizer. And let's see what it comes up with. So we've basically got 2% Doge and 8% Link. What I can do here to try and fix this problem where it's over allocating to one crypto is you can apply a slightly different constraint here. So rather than a particular asset, you can apply it to all, or rather each asset in a class. Again, I'm just pulling this straight from the documentation. If you go to constraint functions here, it's down here. You can see a few different options. So I've lost my place here. We're in here. Each asset in a class. Well, which class I'm going to apply that to? Well, it's class 1. I'm going to apply that to crypto. And we're going to say that you can't have more than 3% in any given crypto. Now let's see what it comes up with. Again, reload our constraints. Rerun our optimizer. Rerun our plotting. So it seems to have done something a little bit more interesting here. Let's run our report. It looks like basically 90% S&P 500, 3% of each of these, and then 1% Bitcoin to make up the loss here. So that's the kind of thing that you can do with these constraints. I think they're really cool because it essentially helps you take some rules that you might have for your own personal portfolio. Let's say you don't want to go over 20% crypto exposure. You can write down all of those different rules, which assets you want to use, that kind of thing, in a nice, human-friendly, readable format here. And you've got all the power of the optimizer from Riskfolio to tweak things ever so slightly once you've already got some kind of framework in place. And of course, there's thousands of different combinations that you can use of all of the different methodologies, whichever one is your favorite for doing portfolio optimization. There's basically all of them, or at least all of the standard ones that you'll find in your quant finance textbooks. They're all implemented here in Riskfolio, and you could always add your own. And so that's it for this video. You should be now in a good position to go out and explore the documentation for yourself and use Riskfolio in your day-to-day portfolio management. So I hope you enjoyed the video, and I'll see you next time.